right. We're talking about combustion reactions in the last slide and how to balance them. So always start out first with balancing the carbons, all right? And then the hydrogens, and then followed by the oxygens. So this is a typo. This should be C3H8, and therefore you need to have 3 carbons on the other side. H8, okay, which would mean 8 hydrogens, so therefore you have a 4 in front of the water. That will give you your 8 hydrogens. Then just count up the number of oxygens, so that's 6 plus 4, 10. So that's why you have a coefficient of 5 in front of the oxygen. All right, so we've done this before, and it doesn't matter what the hydrocarbon is, just follow the same principle. First carbon, hydrogen, and finally oxygen. All right, alkanes are nonpolar. The bonds are CH bonds are nonpolar, insoluble in water. They're less dense and flammable. Crude oil, the oil spill is because when there was the oil spill, um, all of the oil just floated on top of the water because it didn't mix with water, and so they had a hard time cleaning up that oil spill, right? Because the surface of the water was thick with that oil. All right. So they have to use things that can pick up, that attracts the oil, something non-polar, all right? And then it's can be then scraped off, all right? Or certain bacteria, etc., that can live off the oil and break it into less harmful uh, products, or use something like that can skim the oil off the top, all right, and that kind of thing. Butane is used in the cigarette lighters. Again, like propane is used in those little tanks, for the propane tanks, for when we use them for grilling and stuff like that. So butane is the fuel that is used in lighters. Okay. All right. It says write the balanced equation for the complete combustion of butane. All right. So again, C4H10 plus O2, giving CO2 plus H2O and a lot of energy. So start with balancing the carbons, make sure there's 4 CO2s and there's 10 hydrogens, so there has to be 5 H2O. Count up the number of oxygen and then finally balance the oxygen. So in this case, for example, if you just had 4 CO2 and 5 H2O, right? So that would be 8 plus 5, which would be 13, all right? So 13 O2, which would then 13 oxygens, which means that you needed to have something like 6.5 oxygens. O2, 6.5 O2. You could put down the fractional number and then make it into a whole number by multiplying everything by 2. So then 2 butanes and then 6.5 times 2, that's 13 O2. And then the 4 CO2 becomes 8 CO2, 5 H2O becomes 10 H2O, and so on, right? So that's another way. When you have some odd number, then make sure that you put down that fraction and then multiply the whole equation by 2. Okay. Right. This topic 12.5 deals with what I mentioned as alkenes and alkynes, the double bonded and the triple bonded hydrocarbons. They're referred to as unsaturated hydrocarbons because of the fact that they have double or triple bonds, all right? So here you see ethine, all right? It's also commonly known as acetylene, and it reacts with oxygen and produces a big flame that can be used in welding, etc. Okay. So they're unsaturated hydrocarbons. they don't contain that maximum number of hydrogen atoms to have all single bonds, okay? So that means they can react with hydrogen gas and increase that number of hydrogen atoms and become saturated or alkane single bonds, okay? So you can't have an alkene with just one carbon, so the minimum is 2 carbons. And if you have a double bond between those 2 carbons, okay, eth means 2 carbons, so you have a double bond between those 2 carbons. That means instead of 3 hydrogens on each carbon, now it's reduced to 2 hydrogens, all right, okay. So the number of hydrogens is basically double, all right? So CnH 2n, all right? If n is the number of carbon atoms, then the number of hydrogens is twice that 2n, all right? Okay. All right, so these alkenes are, because of the fact that they have this double bond unsaturation, they are able to add on hydrogens and become alkanes, or they're able to add on water, HOH, and become what is called as alcohol, right? That OH, it's the OH is now called as a functional group, and that belongs to the group called as alcohols, okay? The organic alcohols. All right, around each carbon, because there are 3 electron groups around each carbon, all right, the double bond is considered as one single electron group. So therefore the shape around each carbon is trigonal planar and 120-degree bond angle. Okay, and then you have ethene, and that's commonly called as ethylene, all right. So it's important because it helps in the ripening of fruits, etc., all right. And so usually what they say is if you have unripened fruit, you can put that in like a brown paper bag in order to kind of enclose that gas, trap that gas, and help in the ripening of fruit to be faster, okay. Alkyne is triple bond, all right? So there's a carbon-carbon triple bond. So instead of a C double bond C, it's a C triple bond C. And just as you saw in ethene, when you had the double bond, now you're reduced to 2 hydrogens on each carbon. Suppose you have a triple bond, then there's going to be 1 hydrogen on each carbon, all right? So that would be ethine, okay? So the number of hydrogens is equal to the number of carbons, so CnHn, all right? So if n is the number of carbons, the number of hydrogens would be exactly equal to the number of carbons in alkynes, okay? So 2 carbons, 2 hydrogens. So in the triple bond, it has to be a linear arrangement, okay? Because you have 1 hydrogen around the carbon and a triple bond, so 2 electron groups, and that's linear 180-degree angle, okay? All right, identify each of the following as being an alkene or alkyne. So the double bond indicates it's an alkene double bond. The triple bond indicates it's an alkyne, okay? And then you can go on further by naming it. So if you look at the parent continuous chain, again, you want to make sure that double bond has got the lowest location number. So 1, 2, 3, 4, 5, 6, 7, 8. So it's octene. The double bond is at the 3rd carbon. The beginning of the double bond, that's the location number. So it's 3-octene, okay? Similarly, you want to give the triple bond the lowest location. So look for the longest continuous chain. This is carbon 1, carbon 2, carbon 3, 4, 5, 6, and 7. suppose you went this way, it would be 1, 2, 3, 4, 5, and 6. So you want to have the longest continuous chain. So 1, 2, 3, 4, 5, 6, 7. So that would be hept ein. Okay, hept ein. And it's of course one heptine, because it's between carbon 1 and 2, the triple bond. And then at carbon 3 you have this branch which has 1, 2, and 3 carbons. So 3 propyl in alphabetical order, right? 3 propyl, 1 heptine. Okay, so 3 propyl, 1 heptine. Okay, so when you name these alkanes, alkenes, alkynes using the IUPAC method, again, make sure that you, if there's substituent, give it the lowest location. If there's double and triple bonds, that's always going to be at carbon 1 and 2 if there's only one double or triple bond, all right, if there's just 3 carbons, right? So comparing ethane, ethene, ethine, okay, their common names are given, ethylene and acetylene. And then you have, if you have 3 carbons, it's propane, and then propene, because it's all, the double bond is always going to be between carbons 1 and 2, even if it was over here. And then propyne, again, you don't have to give it a location when there's just 3 carbons. All right, how do you name these alkenes and alkynes? Look for the longest chain. Look where that double bond is. You want to make sure that that double or triple bond gets the lowest location number. So start from the end where it's closest to, and then look for any substituents and give it also the location number and the name. All right, follow the alphabetical order to name this alkene or alkyne. Okay, so write the IUPAC names for the following. So you have, you want to start from the end where the double bond is. So 1, 2, 3, 4, and 5. So it's between carbon 2 and 3 is the double bond, so 2-pentyne, right? But then at the 4th carbon you have this methyl group, all right? So 4-methyl-2-pentyne, okay? All right, and now you want to start here from this end, 1, 2, 3, and 4. So bute, what did I call this? Sorry. So ene. So 4-methyl-2-pentene. Okay. And then this would be just 1-butene. All right, because it's the triple bond is between carbon 1 and 2. So 1-butene. Okay. Oops, I made a mistake here. This is 5 carbon, so that is pentene, 2-pentene. There is a branch here, so that's a methyl group at carbon 4, so 4-methyl-2-pentene. I don't know why there's 6 carbons here. So you have 1, 2, 3, 4, 5, 6. Okay, sorry, I made a mistake. The where the double bond is, it indicates there's 2 carbons there. There's a carbon here and another carbon here. So total of 6 carbons are hexyne. So 1 hexyne, all right, okay. So 4-methyl-2-pentene, and then oops, this is carbon 1, so 2 hexyne, okay. So apologize. So it's between carbons 2 and 3, the triple bond, so 2 hexyne, okay. And there's no substituents on this one. Okay, how do you name the cycloalkenes? All right, just like you have cycloalkenes, you can have ring structures with double bonds, and those are called as cycloalkenes. All right, so the double bond always get the smallest location, so that's you go in the direction clockwise or counterclockwise to give that double bond the smallest location number. And we'll stop here and continue.